Welcome to this talk. We're going to talk about M for about an hour. We're going to show you everything you need to know about M in less than a kilobyte. We're going to write a bunch of M. We're going to get to the M as quick as we possibly can, and we're going to generate under a kilobyte of UTF-8 text that I believe will tell you everything you need to know about the language. Okay? I'm giving this talk with my good friend David Langworthy. Dave's been working on the language longer than I have, and he is just an encyclopedia of in-depth knowledge and trivia about the language, so hopefully between the two of us we can field any kind of question that comes up. So why don't we go ahead and, there we go. So what is Oslo? Oslo is three things. It is a language, it is a tool, and it is a repository. Why are we doing Oslo? Because we believe we need better ways to capture the intent of the developer, the IT pro, the end user, to capture that intention into a machine processable form that we can then use to go drive the execution of our software. The best comp for what we do in the shipping platform is XAML. Right? XAML is a great example where we capture your intention about how you want the design of your forms to look or your pages to look, or how you want the business logic to be arranged, flowcharts, state machines, rules, etc. We capture that as data, and then we take that actual data and run it. And we load it up at runtime. That's what we do in Oslo. So Oslo is enabling technology to allow those kinds of things to happen. And so to do that, we're building a repository so we can hold all that information together and relate it and join it and do all kinds of fancy queries with it. We have a tool called Quadrant, which lets people interact with that information, get in and touch it, feel it, get an emotional connection to it. And then, because at the end of the day, a lot of us are developers, we have M, which is a language. Great. So, why did we do M? Let me tell you a story. The first milestone of Oslo, we did not have a language. We had this goal to allow developers and to allow all kinds of users to capture what they wanted their software to do as data, stored in a structured form so that we could then use that to drive runtimes. And the way we approached that problem in our first milestone was we had a box and arrow tool for capturing that information. And if you wanted to write a model for how your system was going to work, you sat in a box and arrow tool and you dragged it out. Now, there's some people who like doing that, but most of them aren't developers. Right? Developers have an emotional connection to their text editor. Right? You're an Emacs person, you're a VI person, you're a Slick Edit person, you're a Visual Studio text editor person. It's an emotional bond that a man or woman has with a machine. It is through the text editor. Right? And so what we found was, by not allowing people to express themselves in text, but requiring them to do this media change, this change of medium, they weren't productive. They weren't fluent. They didn't attach to it. It was this otherness. Right? It was like the TPS report they had to fill out, not the code they wanted to write. And so what we realized after the first milestone was we were going to fail. That if our premise, that if our ideas were predicated on having developers use box and arrow tools, we were doomed to failure. And so we decided after the first milestone of Oslo to look at having a language so that we could allow people to write down these ideas, these intentions, in the text editor of their choice, with all the features they expect from their text editors and all the benefits of having text. Right? We wanted to make that a first-class concept in our platform, and hence M was born. Now that doesn't mean there's not a role for box and line tools. That doesn't mean that just because I like text, I have to hate boxes and arrows. But what we observed was, if I don't have text, I don't care about boxes and arrows. And so having text was super important to what we were trying to do. That's why we did M, and let's go ahead and talk a little bit more about how it works. So, what is M? M is a language for defining domain-specific models and domain-specific textual languages. So there are two primary components to M. The domain modeling part, which we often call M schema, allows us to write schema and query over structured data. And in the realm of domain models, or schemas, we have concepts like values, constraints, and views. There's a natural projection from the M domain model down to SQL, Because you might remember from a couple slides ago, we have a repository which we're building as part of this platform. And we want that SQL to be a natural SQL database, not one of these crazy property bag, meta, God knows what, shoot me in the head now, I can't stand it. We want it to be a plain old SQL database that you can point Excel to. Right? That was the premise. I want to have the data in a natural form that I can perform queries and joins on. So the domain modeling language has a very strong affinity to the relational model. Actually, it is based on the relational model and a strong affinity to SQL. And it allows me to write queries, views, and values. The other part of M is the textual DSL layer. That is the ability to control what the textual representation looks like. Just like when we talk about quadrant tomorrow, some of you may come to the quadrant talk tomorrow. We have some default views for seeing the data in the repository diagrammatically. But we also know there you want customization, and you want to be able to control exactly what it looks like when you're doing box and line work. Similarly, when we're doing textual modeling, we have observed, just through kind of some hard-won lessons, that people want the concepts from their target domain to surface up through the language so that there are peaks and valleys in the text. So that you can see, that's important, that's a keyword, that's bold. This isn't so important, it might be punctuation or just some non-interesting delimiter. So we have the ability to write textual DSLs using M grammar, the other part of M. Now that's part of the language we're not going to cover in this talk. There's an excellent talk which will surpass this one in quality and excitement Thursday. It's being given by Chris Anderson and Gio Della Brea. That talk will talk about the grammar parts. This talk is going to talk about the domain modeling parts. We'll touch a little bit on the textual DSL side, but if you really want to wallow in that stuff, come back Thursday for the other talk. Cool. So here's how the language stack works. The M language has two primary components that are both built on a common foundation. At the bottom, we have a simple data model based on label-directed graphs called M-graphs. And this is the way we structure all of the information in our system. We basically have graphs of nodes, and the graph nodes have labels. So you'll see a simple representation of some data at the bottom, which is a point. Looks a lot like JSON. We have the ability to put textual surface areas on top of those M-graphs, so that instead of writing that syntax, I can get a syntax that's very tailored to the domain or task at hand. We call that M grammar. And we also have the ability to schematize those graphs with M schema. Make sense? So we use M schema to build domain models, which are basically schemas over structured data. We use M grammar to build transforms from text to structured data. But they bottom out at this bottom simple graph data structure. Now when I'm inventing something for use in this world, I will inevitably write a domain model because I care about what the shape of the information is that I want to capture from the user. And if I'm going to write programs against it, or if I'm going to write queries in the database against it, I'm going to want a schema on top of that. And I can live a full and rich life just using M grammar. I'm sorry, just using M schema. However, if I know that I'm going to have lots of people interacting with my system and creating data for those schemas, and I want to give them a very customized, tailored experience as they're writing the text, then I write a grammar for that as well. You can use either one, both. The system's pretty modular this way. Great, Dave? So let's talk a little bit about what M is not. When we start showing you some M, your spidey sense is going to go off and it's going to send you a couple of mixed signals. We use curly braces, right? We use curly braces. The curly brace is one of the most beloved punctuation marks on the planet, and we embrace it fully with this language. That stated, we are not an object-oriented language. We're a language for data. So M is about capturing and schematizing and transforming data. In the realm of data, we just have representation. We don't have behavior embedded in that representation, right? So we don't have polymorphism. We don't have virtual dispatch. And the way we do our typing in M schema, in the M domain models, is we use structural typing. Unlike most of the object-oriented systems that many of you use, not all of you use, we use structural typing, which means if the shapes of the data match, it's the same. Right? Rather than having to say, this is a that, this is a that, right? We basically look and say, does the shape of the data match the shape that's expected? And do the constraints line up? And as you'll see when we talk about how we write types down in M, all types in M schema are constraints. And so we're really just doing constraint intersections. So M is not an object-oriented language. It is also not a data access technology. Dave, I don't know. This may be the first PDC ever in the history of Microsoft where we didn't introduce a new data access stack.
My.
Tell you this much, we aren't doing it in this talk. M is a language for writing schemas and values. The M domain models that you write compile down to T-SQL and execute in the database. Now, we do have the ability to write values in the language and have them appear in the database when I install my schemas. However, do not go build your OLTP application using this technology, because that's not what it's for. That is, our tool chain is not a data access technology. It's there for installation and extraction of the modeling information that you're putting into the database. We are not a data access stack. And finally, we're not a replacement for T-SQL. We live at a somewhat higher level of abstraction. We normalize some things that you actually want control of if you're a T-SQL DBA or a hardcore T-SQL user. We have a far less expansive feature set. There are lots of things in T-SQL that pretty much the entire product of SQL Server is exposed through some sort of T-SQL construct. We don't do those in M. However, those of you who want to write M domain models and bring in pieces of SQL to go along with them, our toolchain supports linking raw T-SQL in with the M domain models that you write. A good mental model, which you might want to think about, is M is to T-SQL as C is to assembler. Right? As you know, when we started writing C, we have ASM modules. We bring them in. Similarly, we have this higher level language, and if you're comfortable with that language, if it does what you want, use it. If there are things you need, we have escape hatches so you can actually start using T-SQL with it as well. Great. So here's how the system works. Right? Guy walks into a bar, he starts writing models in M. Right? So I start generating text files with my text editor of choice, and I write down my M models, and then I run them through the model compiler. The model compiler is m.exe. m.exe loads up the models that I write in text, checks them, model checks them, does a variety of things to make sure that they're type correct. And then it takes that and puts it into an image file. A binary image file that we can then use either to install into the database or use for subsequent compilations. So in this world, the thing on the left, the .m files, are kind of like .cs files. The thing in the middle, the .mx files, are kind of like .dll files. And as you know, sometimes the .dll file is there so you can load it up and run it. Sometimes it's there so you can /r it or add reference it from Visual Studio so you can write other programs to take advantage of it. That analogy holds up exactly here. So, Dave, click the next slide. I think there's a, yeah, there it is.
There we go. So what we're going to do is write a little model, very simple model. There'll be another talk. Chris Sells and Martin Gudgeon are going to do a big model. But as Don said, we're going to try and write a small, simple program that shows you all the key features of this M language.
In less than a kilobyte.
In less than a kilobyte. And there's 3 key features. There's values, constraints, and views. And it all just comes up from there. So can we get a module? M has a module system. This is a container that controls visibility. You can also think of it as a unit of deployment. So we have a module contacts. And let's create an extent. An extent is where we store values. We'll create an extent for people. And we have values, which are just name-value pairs. Name equals Robin Reynolds. And an age equals, let's say, 23. Actually, you can pick. And let's do one more. Terrific. Oh, what did you do? All right. I didn't see it. I wasn't looking at the monitor. I guess I should keep my eyes on.
Coincidentally, I picked the same age that you did, Dave.
Oh, that's nice. Thank you, Don. Who are we doing next? Chris Smith.
Window creativity for me, please.
Type what you wish. There we go. Okay, so that's it. That's a model. we have values. What we can do with this is run it through the tool chain that, that Don just described. M is the compiler. We can take and compile that. Compiling, we're going to need m/p image. So we're going to compile that and produce the image file, which will be named the default contacts.mx. Can we show them what's in there?
No, I wouldn't run it. I would instant gratification. Make it work. Make it work. Make it work.
Let's go. All right. So let's type mx, which is the loader, /i contacts.mx /i colon contacts.mx, and then /d window of creativity. We're also going to need a /f and a /c. /c says create me a database, and /f says just force it. It's sort of a rad development mode. Okay, so what has happened there is that MX has taken the image and loaded it into SQL for us. And you can use whatever data access technology you like to go get that data. We like SQL command. So SQL command -d window do I think it may just be -d.
Whatever you say, boss.
There we go. You don't have a window of creativity there. So let's go select star from. The module name projects as the schema name, and the extent name projects as the table name, right? So from contacts.people. Go. Blam. It's there. We got data. Wow. This is like really, really exciting. We didn't have to take and schematize all this data before we went and wrote a model, right? We just type the data in. The compiler goes and figures out, you know, what the types are, what the shape of the data is, and does everything we need. One of the things is, though, it'll let you sort of type in anything, and so you often want to take and constrain what you're putting in there. Let's put in some bad data. Do you want to say like age equals true and put somebody?
I haven't constrained it yet.
No, go ahead and put in some bad data. It'll work. You'll love it. True. Let's do. No, don't do that. We're going to go constrain it. Don't go that far. But you see, we don't get any errors. You can also take and put a. Well, let's just go with it.
All right.
Okay, so now we're going to go and constrain it, and we'll, there you go. Let's go constrain that. So we'll create people, we'll pre-allocate the extent, semicolon, there we go. So that is just saying we're going to have a people, and we haven't said anything about it. We're going to take and constrain that using the colon operator. And I'm going to say we're going to, and the types look a lot like values, but have types in them. So we'll just say we have a name field, name semicolon, age semicolon. There we go. So we've got that. We've said we've had a name and an age. We've got a lot of red squigglies. That's no good. We actually need a collection of name and ages. And the way that we say a collection is with the star operator, like from regular expressions. We could also, so here we say we've got a collection of name and age, 0 to many. Now Don has gone and said we have 1 to many. You could also say a collection of 2 or 2 to 6. So you can constrain the cardinality of a collection there in a very compact way. Let's just go back to star. Just, we haven't said anything. Put that as true. And so...
I don't want that to be correct, though.
Yeah, we don't want that to be correct. Let's constrain it a little bit more. Let's go up and use that colon operator again to further constrain this to name to text and age to integer. And there we've got an error. So we've specified the constraint. The data that we had did not fit it. And so we needed to go and we got the error, changed the data so that it was an integer, which is what we said. And it's all great. Turns out we want to take and often do a little bit more. We want to take and give a size to the data. Integer 32, 32-bit integer is very common. Text, we have the ability to further qualify a constraint with a where clause. And so we'll say where value.count less than 32.
How about 20? Would that be enough?
20 is sufficient.
28.
28 is wonderful as well.
Great.
Okay, great. So now we have a constrained model. Our data fits it. Life is good.
What would the sequel look like, though?
Well, you know, we have the ability to find out. Just go under M and generic SQL preview. It's going to bring up a window that'll do some clipping. Here we have a live view of the SQL that, that this model would generate. This isn't loaded in the database or anything like that, but we can take and make an edit in the model and see it immediately reflected in the SQL. You specify an optional or a nullable field with a question mark. You can change these numbers around. Scroll down to the insert statements and change some of the values. So you can see the data very, very quickly. All right. So there's our program. We've got our value. We've got our constraint. And so those are two key things that we have in the language. Now, we want to go a little bit further than that. And before we get to the views, we want to talk about relationships or references. References are just values in the programming language. So, but we need to have an identity on the types. So, and an identity lets something be referenced. So, and we state identity again with a constraint. So we'll say where identity name. And just for the purposes of this demo, we're going to take and use name as the identity. You could have a surrogate or whatever you'd like.
So Dave, what you're saying is, until I imbue a collection with an identity constraint, I can't actually refer into it.
Correct.
But once I imbue it with the identity constraint, then I can now start using that data in other schemas to refer to it.
Yeah, exactly. So, all right, let's go and create a relationship, marriage. And let's define the type for that. So we'll just have a type marriage, and being equal to all, we'll have spouse A and spouse B. So that defines the shape of the relationship. We're going to say that it's a relationship between people. There we go. And so we're about ready to go and create values for that. Let's allocate an extent called marriages. Give it a type marriage star. Let's create some room for some values. Let's get going on that. Spouse A equals...
That one right there. I want that one.
You want that one?
Yes.
Well, it'd be nice if
I just drag and drop it?
No, you can't drag and drop it, but we can give it a name. We could give it a nickname. We could call that Rob.
Okay.
There, Robin. You can name that one Chris. Okay, so this is kind of cool. We've got these labeled values. This is going back to this mgraph data structure. And we can just take and type these in and use these. We get all the completion and everything like that that we have for types and things like that. So here we have a whole new model. We've got some relationships. You want to go look at this in SQL?
Yeah.
All right. So you did save. We run it through the tool chain again. We're going to create our image file. Want to look at the image file this time?
Not just yet.
Okay.
Do you?
We're all good. Incompatible schema found.
Oh,
you need the WACF and the WAC-C and the WACF. The tool does a limited amount of diffing to try and load, but if it sees anything that looks screwy, it says, no, I can't do it. All right, so let's go to our favorite data access tool, SQL command. And we can do select star from, we need contacts dot marriages. There you go. Go. And so we see the relationship is projected in there. And it's got those names because we specified those names as the identity, and the identity projects as the primary key, and it's also used as the foreign key.
So Dave, I have a question. I've done a little bit of T-SQL in my life. Does it matter what order I put the text in this language, in terms of dependencies, of inserts? Because I know that...
One of the nice things is the compiler and the loader will go and sort out the orders. If you have a cyclic dependency, it does its best. There are some cases that it can't sort, but by and large, it goes and figures out that the inserts for the references need to go in afterwards. Actually, you could take and move marriages up, and you could see that there's not a sequential dependency in the file. So now we've got a couple of things are wacky there. He's got the data before the type declaration and before the data it depends on. We'll take and compile that. We can load it again, load with that WACF option. It all did it, and we can go in and look. And it's all still the same data that is that's in there.
Sweet.
Great. All right. So we've talked about the values. We've talked about the constraints. The last thing are views. Views are just functions. Let's just write a simple function over this and get the people named and pass in a parameter with that name in as of type text. So we can just say people where value.name. We use this where clause again as a constraint, equals n. All right, so that is a query. It will take and create a function in SQL for you. We could take and type this. It's a compact query. We could take and type this, a full length query expression in here. From p in people where p.name equals n, select p, if you prefer. So that's also a perfectly valid query. And since this is a common pattern, we take and lift the fields on values up to members of collections. So you get indexers on there. So this thing here, people.name with n, will go in and get the members of that collection whose name field is equal to n. It's equivalent to the previous two expressions.
Great. Shall we compile it and try it out?
Compile it, run it. So what we've seen so far are the values, the constraints, and the views. There's bigger models, more complex models, but this is all you really need to get pretty sophisticated things going. Contacts.people name Alice.
Well, oh, fine.
There you go. Nobody named Alice. I think we got Chris Smith in there.
Cool.
Great. That's that.
Great. Thanks, Dave.
Tell us where we're at. Thank you.
Cool. Dave, do me a quick. I just forgot to go to the shelf. Go to the shelf. Go to the shelf.
Go to the shelf.
Do a dir. Let's get a byte count. 726 bytes.
726 characters, including white space. We use no tabs.
Yeah, you're right. We use tabs, not spaces, so that's a higher bar, isn't it?
Tabs, yeah.
Great. So slides back. Please, 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 please. Slides next. Cool.
Snap your fingers.
Great. So what do we see? We saw how M schema allows us to put values into text, right? We started with that people thing. We just start writing down our values. And often when you're just getting started, you just start typing stuff in, and the shape kind of emerges as you go. Certainly someone's been using M for almost a year now. I find that it's just a very easy way to sketch out data, and not having to pre-declare the types up front means I can get stuff going and get kind of the RAD experience going much, much faster than if I have to take a more disciplined approach. That stated, right, we have a very rich constraint-based type system that lets me come back either upfront or after the fact and apply typing and constraints on top of the data that I've already defined. And in fact, what's really interesting about the way structural typing works, including in our system, is I can actually have multiple different schemas that map to the same underlying values, because I'm really just matching shapes, not based on this value is hard-coded to that type. Rather, there's a strict separation between the types and the values. Cool. We saw that we do references with identity constraints. I mean, we saw that I can write rich query expressions and make them into parameterized functions in the language. Cool. So that's what we just saw in the language. What I want to talk about now is, for a little bit before we stop, is how we actually expose this machinery to you folks. Do you remember when I started this talk and I had the slide with the M grammar and the M schema? We talked about how we have domain models and we have textual DSLs. Well, it turns out you just saw a textual DSL, right? So M schema is just another language written in M grammar. And so M is itself implemented as an MDSL. The parser for M source text is exposed to you using the MDSL machinery that's part of the Oslo SDK. So if in your imperative C# programs or in your tool chains, you want to be able to take M definitions of models and then do further post-processing on them, whatever you want to go do with them, we basically give you the output of the parser, just like we give it for any other textual DSL, and you can go party on the data that you got back from the parser. Now, the data structures that come out of the parser are pretty good, and they're pretty useful, and they're actually really great for generating M models. But often what you want is when you're consuming things, like if you're building a back end or if you're putting this into your tool chain, often what you want is the fully type-checked M. That is where we've collapsed all of the references, we've made sure many of the constraints have matched, all the ones we can validate statically, some of them have to get validated dynamically. But all of that stuff we also expose to you as the output of the type checker. So all these things are framework components that are part of the Oslo SDK, and you can go build all kinds of things with them. One of the things that got built on top of this, kind of late before PDC, was this thing called Mr. EPEL. Right, some of you folks who may come from functional programming languages or old languages are used to REPL, which is read, evaluate, print loops. And so we actually, one of the devs on our team, Josh Williams, also known as Spanky J, because we all have nicknames. So Spanky wrote a REPL program and then plugged it into our textual environment. Why don't we go take a look at all this stuff?
Okay.
So Dave's going to crank it back to the version of iPad that we had running, I think. That'd be good. And what we're going to do is we're going to bring up a new text buffer, and we're going to put this thing into REPL mode. Actually, no. Hit escape. Hit escape. Go back to the program we had. Just Control-Tab. In the M mode, you can actually see both the DSL output of this specification. So if you go to the M mode command window, or the menu, and say AST, so remember, M schema is just another DSL. Here's the output of the DSL parser exposed as a C# object model, so you can just cons up these models programmatically. And here, the way we wired it into the mode is we actually just serialize it out to XAML. So I can take the output of a parse episode, serialize it to XAML, and be done. Cool. If I want to see the output of the type checker, if you go to the M mode semantic graph, this is further down the compilation pipeline. After we've done all the parsing, we figure out exactly how the constraints line up, what types go with what values, et cetera, et cetera. And so all of that stuff is serialized into a different object model, which is shaped based on what you want when you're actually consuming M. So basically, we make it easy to programmatically produce M with the parse trees and consume M with the semantic graph. And all that stuff is part of the framework, and we also let you see it in the tool, which is kind of fun. Now, let's go look at the REPL mode. So go ahead and close those two windows. Thank you, Dave. So what we're going to do now is use Spanky's REPL mode. So we're going to go into set mode. Right? In the text edit environment we're using is highly extensible. We have modes for them. And we're going to go into mscript mode. And what this does is it lets us interactively load M modules and write M expressions and do all kinds of stuff. So why don't we go ahead and load up the MX file that we just wrote. Do you think this will work?
I hope so.
Okay, cool. So Dave just loaded the M source text that we wrote in the file buffer behind us. And what he's going to do now is, do we need to do the push module thingy?
We can show them.
Great. Oh, yeah, great. So show us something.
So it can't resolve people there because we're not inside the module. The module controls visibility, right? So what we need to do is move into that module.
So the answer is yes, we do need to do this.
Yeah.
Okay,
now
great.
everybody knows.
Yes, they now know. Thank you,
Okay.
Dave.
You're welcome,
A
Don.
simple yes would have sufficed, but just me. Cool. So what happens when I type people now? Cool.
Forget the people.
Can I write an expression over people?
Sure.
How do I do it? Will you pick an expression, make one up?
Oh, let's do that one.
Cool. Excellent. Can you, I know we have this thing in M, which I really love this feature. It's kind of cool. I kind of wish I had it in my other languages. Because when you do the property name with the paren, we're basically taking a row. We're taking all the rows that match that.
Oh, huh?
But we also have the ability to take a vertical slice out of the data. Can you show me that one?
Yeah.
And can you scroll so it's at the top of the window? Or is that not a feature of this tool?
Well, it's not,
We're adding scrolling in M3.
it's a feature of the tool, but I don't know that it's a feature
It
of
always
the
has, well,
resolution.
you could resize the window so we can only see a few, maybe some fewer lines.
Can you see it now? Can you hear me now?
Can you see the bottom line in the back? Yeah, I told you. I told you. Just collapse the window, dude. Collapse it.
Collapse the window. PEO.
No, just resize the window.
Resize the window. Don, that's what I did.
Oh, okay, fine.
We're
fine.
having scrolling issues. There we go.
Oh, excellent. Go, Dave.
See? There we
Cool.
got that.
Now, if Dave just says people.name with no parens, it's actually, because it's a collection, the index is going to go off and pull off a vertical slice out of the data. So when I go people.name, I see that. If I say people.age, cool. And these things compose, right?
Yep.
So how about if we do, what do you think? People dot, we don't have any common, actually, can we add more data? Can we put another person in the extent?
Sure.
Great. So what we'll do is we'll declare another value that'll get unioned in with our extent. So people, open curly brace, open curly, name equals, scroll.
Scroll. Let's see where we're getting with this.
Oh, Dave, it's going to crash. It's going to crash. You didn't close your quote. You didn't close your quote. Avert your eyes, please. You do not want to see this.
We'll just
Oh,
try it.
God, Dave.
Okay. No. All right.
Try again. Do it again. He will. Let him type. Don't distract the man. He's typing and he can't do two things at once, you know. We're all this way. He's very monomaniacal, very focused guy.
All right. Does that look good?
That looks much better.
Okay.
Cool. Can you just bring that up a little bit with your mouse? Will that work?
No.
Is it full screen?
No, it's not full screen. This is, there's something funny going on.
You're not maximized? He is. Click the unmaximize.
Okay, there we
now
go.
you can scroll. Dude. Oh, yes. Oh, yes. Dave, you are my hero. So now, can you see the bottom line now? Don't bother to scroll. You don't need to scroll anymore. It's okay.
All right.
Did you add that row yet?
I added it once.
Oh, yeah. Do we have an identity constraint? We do. It should fail the second time, so don't do that. Pick a different one. Add one more. Let's do another 23-year-old. People. Name equals maximized window. Max window, yes. Great. I love that guy. He's 23 as well. Taking 23 minutes out of this talk. All right, Dave, that looks so beautiful. Let's see the whole thing. Type people. I want to see them all. I want to see all the people in the extent.
Oh no, where are people?
Oh. Chris, you know what he did?
That's no good. Well, we're live.
I have seen this work so many times. What I want you to do is just a moment. Imagine it had worked for a second. Oh, no. Quiet. Imagine it worked. Wasn't that great?
Whoa! All right.
I think we've shown them all this stuff, haven't we?
Yeah, that's it.
Slides? That's it. Oh, God, I love it. Next slide. So, next. Next, you're going backwards.
Oh, sorry. Go back.
Go back. No, don't show the punchline. Go back.
There we go.
Cool. Fine. Freeze. Thanks, Dave. Oh, Dave, that was great. That was great. So, where are we? M is a textual modeling language that lets us build domain models, schemas, and domain-specific languages, textual DSLs. Right? That's what M is. It is the language of Oslo. It's a great language for doing data processing, data capturing data values, schematizing data, transforming data, querying data. The core constructs in the domain modeling part are values, views, and constraints. And we saw that there's a very nice matching between the way M schema values and data works with the relational model, so we're able to get a pretty good projection down to SQL. Now, what I want you to do is I want you to stay in this room or come back to this room. The talk after this, I promise you, is a talk you don't want to miss. So Tim Mall from the Entity Framework team is going to talk all about what they're doing in the Entity Framework. He's also going to speak a little bit about what those guys are thinking about doing with the stuff we're doing in M. So I think that talk's going to be great, independent of the connection to M. But I really think you should hang out there. So I got to tell you, I'm going to take questions, but that's it. So questions are, mics are at the middle of the room. Give it up for Dave, by the way.
Thank you.
Questions? Yes, a talk can end early. I'll answer the first question.
Would it be possible for us to see the final generated SQL for the...
Would it be possible to see the final generated SQL? I am so thrilled you asked. Dave, just go back to IntelliPad. Can you go back to the regular, just Control-Tab to the .m file? And if you go to the M mode and just say generic SQL. So there's some preamble which sets up the execution context in SQL. There's a create schema. This is the raw SQL that will actually create the database. When we package it up as an image file, the loader will actually do the schema diffing. So this is the kind of blunt. This is the equivalent to when we do /c/f. So we create a schema. We create the table. Scroll down. There's probably another create table.
Losing responsiveness.
Did it die? Yes, you can see the SQL. Download the SDK and run this program yourself. Any other questions?
Hi, I just want to know where's the value in the service world for this language and also the data resolving that it's doing.
Where's the value? Can you restate the question?
Yeah, where's the value or where exactly its usage in the services world?
So where is this used? Basically, we built a language for schematizing and creating data. That data can be used in all kinds of contexts, but at the end of the day, this is a fairly base level mechanism. If you went to the keynote that Chris and I did, we actually used M to create a DSL so that we could automate a lot of the HTTP web request programs we were writing. So we actually just wrote a schema for what we wanted basically a REST client to look like. We schematized it. We wrote a grammar so we could get that nice syntax on top of it and type it in IntelliPad. And then we used that to drive our program. So really, it's a fairly general purpose mechanism that can be applied in a lot of different contexts. Thanks.
Related to XML at all? I mean,
can I relate it to XML at all? Yes. It's not as beautiful as XML. It actually serves a lot of the same roles that XML can. The difference is you have a syntax that you have control over, and you have an underlying data model that has a very nice synergy with the relational model. Unlike XML, which, as we all kind of know, it's great for transmitting data and exchanging data, but once I put it in a large store and try to query across it, we kind of hit some walls. Next question.
Yeah, earlier you showed the data being stored as XAML also.
Yes.
One of the questions I have is, are you guys going to start using XAML more as a serializer and not tie it directly to WPF?
Great question. We have already done that. Independent of the effort here that we're looking at here, there's a new XAML stack in .NET 4.0, which is the one we're actually using in this tool, which is completely decoupled from either WPF or the workflow engine. Right, you look at .NET 3.0, we had two XAML stacks, which were kind of mostly the same, but you couldn't mix them together, and if you always had to load one of those two big DLLs. So in .NET 4.0, we have an isolated XAML stack you can use for any kind of value representation and object initialization. Absolutely.
So that means it's no
Yeah.
longer tied to the disk?
Dan Roth and Rob Relia, I believe, are giving a talk on it later this week.
Okay.
Great. Next.
Okay. Do you see this one to become a boxes and arrows?
Well, the data M is text. M is for writing down values and schemas and DSLs in text. The data that comes out of this system and gets stored in either a database or in some other form, we absolutely think that we want box and arrow and box and line and other diagrammatic visualizations on top of it, which is why we're doing Quadrant in concert with this work. Right? So if you went to Doug Purdy's talk, they created some data in M, they got it in the repository, and then once it was there, they were able to point Quadrant at it and get all kinds of rich and dynamic views on top of it. So I think the two things are very complementary.
Replacing ER diagrams and other things.
Can you start the question again, because your mic came in halfway through?
Oh. Okay. Do you see this one replacing ER diagrams?
I don't see text replacing diagrams. I think they both will live until the end of mankind.
Yeah. Then
right?
The maintenance, like for example, you started a contacts and people. Now you want to add one more value on top of it.
Sure. Well, let's be clear. M is not a database.
Yes,
right?
true. This is a model.
Right. Well,
so now I have a previous model,
yes.
and I got people, name, and something. Now I want to say middle name and something like that. So how does this M basically create this alter statement and all those kind of things to create a database definition, a schema?
I'm going to try and answer as best I can comprehend what you're asking. You come up afterwards if I don't answer the question you're asking. Mm-hmm. We have the ability to write M, source text, compile it down to SQL. I can change that M over time because it's just text. I can use my standard text diffing machinery, my existing source code control against it, right? And I can use that machinery to control version skew across M modules. I can also take that MX tool that we were using to take the modules and stick them into the database. I can also use that to reverse engineer a database into an M module, right? And from that I can also, I believe, always get source text, at which point I can then start to do different kinds of analysis. And again, we expose most of the machinery as public OM, so if what we do isn't what you want, you're not stuck with what we give you.
Okay.
Make sense?
Thank you.
Over there.
In your examples, you showed projecting an entire row or projecting a single column. What's the syntax for projecting a tuple out of a table?
Great question. I can cons up an anonymous. It looks actually pretty similar to C# anonymous records. So I could have just returned open curly brace, arbitrary new column name equals this, arbitrary new column name equals that. Dave, do you have a copy of the code running? I don't want to go type it. But if you look at the function that we wrote, no, the very top, notice that we didn't actually ascribe a type to the result of that. We typed the input argument, n, as text, but we let the type checker infer the type of the result, and that becomes the implicit type of this thing. So I could have just consed up an arbitrary structure and returned that, and it would have type flowed and would have type checked and what you kind of expect.
Thanks.
Yep. Over here. Yes.
Can you hear me? Yeah. Yeah. How does M support like concepts like semantic web? Does it allow us to do? Do you guys plan to have any tools that help us build grammars?
Well, we have tools to help you build grammars. If you go to Chris and Gio's talk on Thursday, you'll see it. If you come by the Oslo booth or the area, whatever we call it over in the lounge, go look for the big black balloons. There are lots of people there who would love to just sit down with you and show you how to write a grammar. So you can definitely write grammars. In terms of how do we relate to the semantic web is built on RDF and OWL. RDF is a 3-tuple value space. You could model that in M, right? You could schematize that information in M. I know that Keith Short, who works on our team, has done a textual DSL implementation of the Manchester syntax for OWL or RDF or Sparkle. I can't remember which one. But he's actually written, so you can take surface syntax for Manchester RDF and actually get out M graphs, which you can then feed into an XML generator or whatever you want.
Okay. Thank you.
One last question, then we're going to, hold on.
All the way over there. They didn't get anybody.
Hold on. That line, I'm going to drain that queue. You first. Y'all can sit down. Y'all can sit down. You two are up.
Will this help with the impedance mismatch between object graphs, relational tables, and XML trees?
Will this solve world hunger? Absolutely. No. 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 Not the problem we're solving. Sorry. Next.
Did I miss something? When you were going through the MX demo, you said the force command you're using was to force it to recreate schema. Is it going to create change scripts in the future, or
there are multiple efforts within Microsoft to come up with great technology for doing schema migration against SQL Server. And when that technology comes online, we'll figure out how to plug it into the back end. We're not going to reinvent that in a one-off manner here.
I see.
I got to tell you, thank you very much for coming to this talk. It was my pleasure to give it to you. Dave, did you have a good time?
I had a great time. Thank you,
Great.
Don.
Well, thanks
Thank
for
you,
coming,
everyone.
and have a good time at PDC. Dave, show them the book. Show them the book.
Oh, do we have the book?
Yeah.
I don't have a book in there. You got a book?
Yeah, I have a book.
Oh. Show them the resources.
Oh, go to the last slide. Go to the last slide.
Yeah. Go to the last slide. Show them resources. Where are we here? Yeah, so you can get the bits. There's a few more good talks. I'll be available at the that area, the lounge. There's books.
Yeah, come get a free book at the lounge. We got 2,500 free copies, which is only enough for half the PDC attendees. So go get one. And after that, you got to go buy them if you want one. So anyway, there you go. Thanks.
Great. Thanks.